In this lesson, we are going to discuss the different characteristics of graphs. First, we have increasing and decreasing. So when the graph is increasing, that means the y values are getting bigger between the first value of x and the second value of x. If the function is decreasing, that means the y values, or the function itself, is getting smaller between the first x value and the second x value. So in this case, we say that the function is increasing from a to b. So we would say that the function is increasing from a to b and from c to d. And then we would say that the function is decreasing from b to c. So in this case, to do increasing and decreasing, first, please note we always use the x values for our intervals. Always use the x values, which means I know that at this point, this is the point -2, 16, and we know that this is the point 2, -16. So when we're talking about increasing and decreasing, let's do increasing first. It is increasing from this point up to this point. So we are going from -infinity, because that's forever down, all the way up to -2. Remember, we use our x value when we do increasing and decreasing. And the other increasing is from this point, and it is heading up from there. So we will do what we call the union sign, and it is increasing from a +2 to infinity. Decreasing, again, we are looking for the x values. It is decreasing from this point down to this point. So it is from a -2 to 2. Again, always use the x values when creating intervals of increasing and decreasing. So in this case, if you would like to pause the video and attempt to write out all the increasing and decreasing intervals, and then hit resume when you want to see the answer. Okay, so increasing is coming from this to this way. Those are all increasing. Also from here to here, it is increasing. And then from here on, it is increasing. So we would say increasing is from -8 to -2, remember, x values. Also from 0 to 2, and then from 5 to infinity. Those are all increasing. Decreasing is all the way to this point, in between these points, and in between these points. So decreasing is from -infinity, because it went forever to the left as we were heading towards the right, to -8, remember, x value. And then from -2 to 0, and then from 2 to 5 are all decreasing intervals. So in this case, you are looking for those points. Basically, you look for turning points first. So this turning point is -1, -3, and this turning point is 1, 1. You locate the turning points first, and then you decide the increase and decreasing. So it is decreasing all the way heading to this point, and then from this second point all the way down. So decreasing is going to be from -infinity to -1, remember, x value, and then from 1 to infinity. Increasing is where the graph is going up, and so increasing is happening from -1 to 1. Next, we have what is called extrema. that is where you have a local turning point or a global turning point. So in this case, this is an even function. We have one global turning point down here because this is the lowest point of the entire graph. There is no other point of this entire graph that it goes lower. That makes it global. These are called local because, again, they're turning points, but they're only the biggest out of this small area right here. This is the biggest point out of only this small area, and this is the lowest out of this small area, okay? It does go lower later on, and it does get higher later on, but at this particular area, it is the highest and lowest point. That is what is called local. So these would both be local turning points or local min and max. It's a minimum because this is the lowest point of this area, the max because it's the highest point. There is no global max because this graph goes forever up. So there is no physical highest point that it goes. So what we would say is that there's a local max at 0 when x is 2, because this is the coordinate point 2, 0. And there's a local min of -1 at x is 4. So at 4, -1. The global, again, is the lowest of the entire graph. So if we were to graph and we recognized that these were the turning points, what we have to determine is, are these local or global turning points? And so first I realized that they are both local turning points because this graph eventually goes on forever to infinity, and it eventually goes on forever to -infinity. So since they keep going on forever, these are now called local. This would be a local max because it's the highest point of this area. And this is what you would call a local minimum because it's the lowest point of just this area. So you would say that there is a local max of 2.113 at x equals -0.215. And then you would say there is a local minimum of -0.631 at x equals 1.549. Now in this case, again, if you were to graph, you would find what all the points were from the graph, and then you would determine whether the local minimum or max. So first, because this graph goes forever up on both sides, this right here is going to be a local. It's not the highest point of the whole graph because it eventually goes forever. And because this is the biggest point of just this area, this would be a local max. This would be a local min because it's the lowest point of just this area. And this point would actually be a global min because it is the lowest of the entire graph. So you would say that there is a local min at -0.922 at or when x is -1.273. You also would say that there is a local max at 6 when x is 0. And then there is a global min at -3.872 when x is when x is a positive 1.586. So then you could do the exact same thing in this case of finding the local min and max. This right here would be a local max. This would actually be a global min, because if you notice, this actually evens out. It actually doesn't keep going down. It is going to be what we call a horizontal asymptote. This would be a local max. This would be a local min. This would be another local max, another local min. This would be neither, because it looks like it's a turning point, but then it keeps going up. So we only have one global min. Everything else is a local max because this arrow goes to infinity. Now, there is one other way if you need to actually graph something. So, for example, if I graphed maybe an x to the fourth plus x cubed, and then maybe a plus x squared minus 15x minus 1. If we were to graph this, okay, so if you notice, we don't see any turning points. It's actually down here below. So I'm going to change, since this is, I need to see y values that are lower than this. I'm going to make my y value, my minimum y value, to be lower. And let's see if that will show us. Okay, we now can see this minimum. So to find out this point, you would hit second trace, go down to minimum because this is the lowest point, and then you are going to toggle over close, and you need a left bound, which needs to be the left side of the turning point, hit enter, and then a right bound, which is the right hand side of this turning point, hit enter, and then hit enter one more time, and there's a minimum here. So you would say that there is a global, it's global because it's the lowest point of the whole graph. There is a global minimum at negative 13.8 when x is 1.25.